Hey, this is section 2.7, which is called Box-and-Whisker plots. By the way, really quick, this over here, it's possible that in class we will just kind of start off with a random fun puzzle kind of riddle thing. Maybe take a quick peek at it if you want. You can pause the video. I guess the story here of it, the question, is that there's a prize hidden under one of these 5 shapes that have a different color. And so the game show host says, do either of you know where the prize is? But there's silence. And then after a little while, the host asks again, but there's still silence. And then after another kind of short period of at least a few seconds, the host says, like, do you know now? And they both say yes. And I guess the only other details is that Sheila knows the correct shape and Colin knows the correct color. So they both have that information at the beginning. Sheila knows the correct shape and Colin knows the correct color, but they don't know, like, neither of them know both, and then it plays out like this with the host asking. So I guess the puzzle is, or the question is, which shape is it that has the prize if the situation played out like that? Anyway, but what we're really here to do in this video is talk about Box-and-Whisker plots. So this video is going to include all 3 parts, part 1, part 2, part 3. In actual class, it's probably going to take us at least 2 class periods to get through what's going to be in this video, but I think the other thing here is with Box-and-Whisker plots, or I guess we're starting off with a quick example involving a stem and leaf plot. This is a stem and leaf plot. So what we're basically doing is we're taking a list of data scores. Like, that's kind of the premise. You're given in a problem a list of data scores, like a big list of numbers, a big group of numbers, and we're going to be finding measurements, and we're going to be making plots such as Box-and-Whisker plots. Pretty big on the Keystone exam. So if you don't know what a stem and leaf plot is, first, this is a stem and leaf plot. So over here is what's called the stems, and these are the leaves, or the leaves, for each stem. So all of these go with the 30, or what seems like it's 30. It's really more like 300 and 0, so 300 or 302. So the list starts off like this: 300, and then 302 for 302, and then 304 for 304, and then over here, like, these are all the leaves for the 31. So it's not so much a 31, it's more just like 3, 1, and then 1 for like 311. And then these are all the leaves, or the leaves for this stem. So 320 for 320, 322 for 322. And so, long story, or to kind of get to the punchline here for this first page, there's, like, here's the entire list from 300 all the way to 329, and that makes a total of 23 numbers, 23 data scores. So pause the video if needed to get all of this entire list written down. But this is just, it's a stem and leaf plot, it's what it is. And it's a slightly more efficient way, I guess, to just represent an entire list of numbers in a data set. Okay, so I'm moving on, but feel free to pause if needed. So here's the list again, just on my screen, and let's review quick, like, these types of measurements when you're dealing with just a list of numbers, a list of data. And we could find a mean, we could find a median, a mode, we could find the range, and these other things we'll get to, obviously. But let's run through these quick. So what is the mean? Well, mean is another word for average. So maybe you remember how to find the average of a big list of numbers. That's where you do the grand total. So you add up all the numbers and then you divide it by how many values there were, like how many data scores there were. So in this case, it was kind of like pre-done for us here. I'm not going to have you literally get a calculator and do 300 plus 302 plus 304 all the way. So the grand total here is 7,216, and like we said a minute ago, there's 23 total numbers. So we do that division and we get about 313.74. With a mean or an average, it's very common that you're going to have to approximate a decimal. Okay? Next is the median. The median is basically the middle number. So when you put all the numbers in order, and that's something maybe you want to write down, the numbers have to be in order when you find the median, because you're looking for like what number's in the middle. Okay? So in this case, the middle number, the number that falls like right in the middle, where there's going to be what, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers before it, and there's also going to be 11 numbers after it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this 313 is the number that's in the middle. Okay, now maybe I'm getting a little ahead of myself, but sometimes the middle number is actually in between two of the numbers. Here we actually had a middle number, but we don't always have like one of the numbers in the middle. Sometimes we have to go, but we'll get to that soon enough. The mode is the number that occurs the most. So if you look at this list of numbers, which number occurs the most? And there doesn't have to be a mode, okay? Some lists of data don't have a mode. Some lists of numbers, some data sets have more than one mode. But here, what do you think the mode is here? 313, because we have 1, 2, 3 of those. And no other number occurs 3 or more times, so the mode, the number that occurs the most, is 313. Again, feel free to write down little notes like that, most or the middle number, whatever. The range, okay, the range of a list of data, you can think of the range of your throwing arm, or think of the range of a gun, or the range of binoculars, or something. The range is like the scope of the data, like how wide the data is, kind of thing. So literally the range, like we kind of range from 300, the lowest number, the smallest number, to 329, the highest number. So we literally do this, if you remember, we subtract the largest number minus the smallest number, and that gets you the range. So here it's 29. It's like the breadth of it, the width of it almost, the range, okay? Like we kind of range from here to there. So next, we have something called the lower quartile. So what you might want to write down here, I almost wish I had it pre-written here. The lower quartile, another name for it is the lower median, or the lower half median. It's also sometimes called the first quartile. And so basically, to find the lower quartile, you only look at the lower half of the data. So this is my middle number right here, 313. So everything to the left of it, or including this same 313. This is the lower half. So all we're going to do is find the median of just this half of the numbers, the lower half. Okay? And if there's 1, 2, 3, 4, 11 numbers, then the middle would be 1, 2, 3, 4, 5. And then we have this middle number, and then 1, 2, 3, 4, 5. So 306, okay, is the lower quartile, aka lower median, aka first quartile. Now, if you're someone that needs to, when finding a middle number, if you got to do like the crossing out, you don't need to write this down, but boom, like cross those out, and then cross these out as a pair, and then cross these out, and then cross these out as you kind of work your way to the middle. That's one way people find medians, whether it's an overall median or just like a lower median, a lower quartile. And then the same thing occurs with the upper quartile. So again, what you might want to write down is upper median. This is like another name for upper median, or third quartile. So this is sometimes known as the first quartile, and this is sometimes known as the third quartile. So likewise, 1, 2, 3. So just these 11 numbers, we're finding the median of just this upper half of the data. So 1, 2, 3, 4, 5. And then so that number would be in the middle of just these 11 numbers, 1, 2, and then 5 here. So 322. Now the interquartile range, okay, compare it to the range up here. This is going to be a type of range. It's not the entire range, like 29 was the entire range. So the interquartile range is just the range between the lower quartile and the upper quartile. So similarly, we're going to do this number minus that number, and we have an interquartile range of 16. Okay? Recopying this again just for my own screen visuals here, but I think the last thing here in part, see, that's the riddle again. So the last thing here in part 1 is, okay, so how do we make a box and whisker plot? So reminder, this representation with the stems and the leaves, call it a stem and leaf plot. So what is a box and whisker plot all about? Well, here's all we do. We have a number line, because a box and whisker plot is kind of like a graph, so kind of, sorta, and we need to kind of graph it or plot it lined up with a number line. So here we have kind of a number line. Our data is, these types of numbers. So here's kind of the numbers we have here on the number line. And all we do is this, okay? We take the quartiles, okay? The 1, 2, 3, 4, 5, 6. So here we have like the lower quartile, and then here we have our upper quartile. In other words, like the lower median, and then here we have like the upper median. And then we also really care about the overall median, okay? So we kind of find those values on the number line, the lower median, the upper median, and the overall median. And this is, did I mess this up? How this was pre-made? Thought maybe I had this already. Good. So we go 306, 1, 2, 3, 4, 5, 6, okay. Yeah, I don't know what happened here. So you basically draw this box, this rectangle, and then we also have, let me get it over top of that stuff. So there's the box part, starts at the lower median, ends at the upper median, and then we have this line here with the overall median. Then all we really do is we draw the whiskers, and the whisker over here is going to go out to the absolute highest number. So is this going to work out pretty good? Yeah, I don't know what happened with the box. But so that's going to work out. So this is a whisker, and see how it goes all the way out here to 329. And then the other whisker should go down to 300, which that's not working out. So what the heck? So that's going to be the end of part one. So the box and whisker plot, all we really are showing in this plot is the absolute lowest number, the absolute highest number, and then all of the quartiles, all the medians, the overall median, the lower half median, and the upper half median. Part two starts off with a quick review, or like another example of drawing a box and whisker plot. So here's a list of data scores, and they all represent test scores from a random high school biology class. So someone got a 91%, this person got an 82%, all that kind of stuff. And just basically we have to draw a box and whisker plot. So quick review of how that gets done. We have to figure out what the median, and then that leads us to next finding being able to get the lower median, and then also the upper median, and that's going to help us draw a proper box here. And we also need to get the absolute lowest number for the left whisker, and the absolute highest number, or the sometimes called an extreme value, the extreme lowest and the extreme highest, and those are going to be where the whiskers go out to. Okay, now if we're going to do any of the medians, like if we need to find the overall median first, we need these numbers in order, do we not? So if you want to kind of try this example on your own, put these numbers in proper order, and then find all that stuff and then try to draw it. You're welcome to. You can pause the video now, but I'm about to reveal these numbers in order. So when you put the numbers in order, this is what we have. And okay, so what's going to be the median? Well, you could do the whole crossing out strategy where boom boom, that pair, and then those are a pair, and then next highest and next lowest, and then as we work our way to the middle. But let's see, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there's 20 total numbers. So when we work our way to the middle, we're actually going to be like in the middle of 82 and 83. So my overall median is 82.5. Like you're going to want like what number is exactly in between the 82 and the 83. So my median, just to kind of put a little mark here, my overall median is going to be 82.5, because we're going to go in between the 82 and the 83 to get in the middle. Now, I don't want to confuse anybody, so listen carefully to my words here. The lower half, right? When we found the median, in a way, you could think like, oh, there's two middle numbers, the 82 and the 83. That's like they're the two middle numbers. We don't just have a middle number, we have two middle numbers. And then we had to go in between the 82 and the 83 to get like the true median in the middle. And I don't know if you should think of it that way, because now that we go to find the lower half median, some people forget that the 82, this 82, is definitely a part of the lower half, and this 83 is absolutely a part of the upper half. So all of these numbers, including the 82, that's the lower half when we go to find the lower median, and the 83 to the 100, that's all of the numbers in the upper half when we go to find the upper quartile, the upper median, okay? So let's see, between all of these 10 numbers, see once again, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, we're going to have to go in between the 76 and the 80. Now, if you can't do that in your head, which is fine, but sometimes it's the numbers are, you know, easy enough to kind of figure out, just mental math, like what number is exactly in between 76 and 80. If you can't do that in your head, you can literally just find the average of just these two numbers, meaning you would add them up and then divide by 2. Again, it's kind of like you're finding the average of only these two numbers. So whether you just kind of think of in your head like what number is exactly in between 76 and 80, if you kind of split the difference kind of thing, or if you added these up and divided by 2, you're gonna get 78. So right there I need to kind of mark, and I also need, of course, my upper quartile. 1, 2, 3, 4, 5. So here, because it's 10 numbers in this upper half, we got to go in between the 94 and the 96. So again, no matter how you do it, whether in your head or by doing a quick average, we're going to get 95. So now that I have those marked out, let's see if this one worked out better. Yes! Oh. So there's the box part of the box and whisker plot from 78 to 95. And then, of course, the overall median, the 82.5, you got to put that line. And then, of course, the whiskers are super easy. This left whisker is going to go all the way to the lowest number in the list, 55. And then this whisker just goes to the largest number, 100. Okay? So, box and whisker plot. That's all there is to it. Then some quick questions to kind of start getting you to think maybe more analytically about these box and whisker plots, what kind of questions you might have to answer on, say, a Keystone exam. Well, we already knew this answer. How many total students? There was 20. How many students scored above that, or not above that, above the median? Remember, the median was 82.5, between the 82 and the 83. So how many students scored above the median? Well, 10, right? How many students scored below the lower quartile? The lower quartile was right here. How many students scored below this, which just turned out to be 78? Well, 5, 1, 2, 3, 4, these 5, right? And then how many students scored above the upper quartile? Remember, the upper quartile ended up being like 90, well, not like exactly 95. So again, it's also 5, huh? Which, so these numbers, right? Maybe it's occurred to you that, well, yeah, considering that there was 20 numbers, what's going on here? Sorry. Anyway, so as I was saying, this might not have been a surprise to you, right? Like, well, yeah, duh. If there's 20 numbers total, then yeah, there's going to be half of that, 10 numbers that score above the median, because the median's in the middle, right? And then we kind of cut that number of 10 in half again when we start talking about, a lower half median and an upper half median. So yeah, getting this 10 and then getting this as a 5 up, like above this, and makes sense. But to kind of finish off part 2 here, I want you to think about this for a second. Maybe pause the video to think, when would it not be exactly 50% of the data, say, less than the median? Like we could also carry that question over to, saying like, when is it not going to be exactly 50%, that scores less than or greater than the median? Or you could also say, when would it not necessarily be exactly 25% of the data scoring below the lower median, or exactly 25% scoring above the upper median? So you can pause the video if you want and think about that for a second, but basically gonna spoil it here, okay? So last chance to pause the video. Alright, I warned you. So what if you have a situation where there's literally an odd number? Okay? So if you had 9 numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9. Think about what the median is. The median here is going to be what, 11? Because you'd have like these 4 numbers, and then you'd have the 11. I'm going to lock this down here. So you'd have these 4 numbers, and then the number in the middle, right? So if you were to ask like what percent of the data is greater than the median, well, it's 4 out of the 9. That's not 50%. It's close. It's close to 50%, but it's definitely not exactly 50%. So again, just kind of when you have an odd number of values, it's not going to be exactly 50% less than the median. And the other situation is, what if you lock some of this down here? What if you have this? Okay, all right, yeah, so there was 10 numbers, but what if you find the median and you have like these repeat numbers in the middle? Think about that. Like, what if you actually phrased the question, specifically phrased it, what percent of the data scored, greater than the median? Well, the median is going to be 12, because when you go in between 12 and 12, you get 12, So what percent of the data is greater than 12? Well, it's not these 5, it's these 4. So 4 out of the 10 was greater than the median, So again, I guess that's sort of close to 50%, but it's not exactly 50%. So in this situation, it was exactly 50%, that scored above and all that kind of stuff, but not when you have these situations, okay? So that kind of does it for part 2. Part 3. Alright, so part 3, of box and whisker plots. Uh, not too much more, new stuff to kind of tell you about. Really just kind of solidifying what we've already kind of looked at in parts 1 and 2. The front side of this paper, there's 3 examples of, hey, identify all of this stuff. When you look at the data, the mean, the median, the mode, if any, the range, the first quartile, what's the first quartile again? Remember, that's another name for the lower quartile or the lower median. And then the third quartile, what does that mean? That means basically the upper quartile or the upper median. And then you also got to identify the interquartile range, and then draw a, like sketch of the Box-and-Whisker plot for the data based on some of these things, not all of them. So what you should do, really, is what we're kind of doing in class, I'm sure, is you should try these 3 questions yourself. Like, you should pause the video and try these, and I guess also the back. So on the back, they show you a Box-and-Whisker plot, and they want you to answer all of those questions. So there you go. That's what you should do. Pause the video, and then once you try all of it, unpause, because I'll be going through the answers pretty quick. I'm not going to drag it out too much. And again, you could always put the video on a high playback speed, like double speed. But anyway, so pause the video, because I'm about to just run through the answers really quick, okay? So here I go. So, what was all of this about? Yeah, I figured. So the mean, remember, the mean is like the average, so the grand total divided by how many numbers there were. The median would be the middle number, and then the mode, if any, looks like there was a couple of modes. There was a tie, 91 and 132. The range, remember, that's the highest number minus the lowest number. And then, so here, the lower half looks like 103 and 139, because there was the upper half, there was the lower half, and so the interquartile range is 139 minus 103. So let's see here. Remember, Box-and-Whisker plot, we would have needed the approximately 118, 139-ish, and 103 right there. So anyway, remember, that's where we draw the box. The line, that's the overall median, and then we go out to what, 145? And then the lowest, 91. So that's what that one should look like. Number 2, it looks like we had to put these in order first, but that's, to find things like the median. So the mean, you should have got 24.17 approximately. And then for the median, looks like we had to go in between 18 and 22 to get 20. Remember, if you can't do that with mental math, then you can do 18 plus 22, get that total, and then divide by 2. The mode, did you get a mode? Looks like 38 was the mode. The range was 46, which 51 minus 5. And then looks like to find the upper, that'll be the third one. So remember, what's the average, or what's in between 38 and 38? Just 38. And then for the lower half, looks like we were going between 8 and 10 for 9. And then when we subtract those, we get 29. Okay, so overall median 20. And 9, which, maybe right there, I suppose. And then 38. So all of those medians so not bad. And then the line in there. And then so we're going all the way out to 51. That's good. And then this whisker going down to 5. So that worked out pretty good. So there's that box and whisker plot along with all these answers. Number 3, I don't know, you didn't have to write all these out. I mean, I guess you can find all the medians and stuff just by looking at the numbers like this, like in the stem and leaf plot. But I wrote all of them out right here, all the way from 48 to 74. And I guess we only had to find certain things or different things for number 3, starting with the median. So how many numbers were there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So that's an odd number. So I think there's going to be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I think there's the middle number with 10 numbers on each side. So we have like 62. And then the lower quartile, looks like we have to go in between the 50 and the 51. And then the upper quartile, to get in the middle of just these 10 numbers, looks like we have to go in between 64 and 66, which is 65. Remember, lower extreme, that just means the absolute lowest number, so 48. And then the upper extreme, that's just going to mean, the extreme high, the highest number, which is obviously 74. Okay. So, now to sketch the box and whisker plot. I guess I can just use these ones. So again, the overall median is, does this go by ones? 1, 2, 3, 4, 5. Okay, so 60, 62. That's the overall median, and then we need 50.5. Right there. And then the upper quartile, 65. So then, of course, you draw the box accordingly. And then remember, this line represents the overall median. And then this is going to go to the upper extreme, 74. So that's working out right there. And then the other whisker down to 50, 49, 48. Alright, so that does it for number 3, how that's supposed to look. Then we go to the back. And again, just kind of, solidifying our understanding of, what you're looking at when you see a box and whisker plot or answering certain questions. So here's so we don't see the numbers, We don't have the list of all these different ages. But this is the box and whisker plot that came out of a survey, I suppose, of different people's ages shopping at the mall. What is the mean? Well, sorry for the kind of a trick question there, but you can't tell. Like, there's really no way of knowing what the average or the mean was because we don't have the numbers. Same with the mode. You can't really tell. I mean, if you look ahead to this question down here, question J, that says that there was like 68 shoppers that were surveyed and there was no repeats. So with that little piece of info at the end, you can at least say that, well, we know that there was no mode, I guess. So can't tell slash none, but that's only because what was written down here kind of given away. But here's what we can tell by looking at a box and whisker plot. What is the median? Well, remember, that line right there, wherever that's lined up, that is the median. So 48. All of these little notches go by 2. That's not 41, that's 42. And then 44, 46, 48. Did that catch you? Remember, lower quartile, that's where the box, that's like the left edge of the box, so 32. The upper quartile is right there, which looks like 52, 53, or 52, 54, and then 55. We can also tell the interquartile range by subtracting those. We can also get like the overall range by doing this upper extreme minus the lower extreme. This would have been like 66 minus 10. So those are those answers that you should have got. And then these questions. Best estimate for the percentage of shoppers younger than 48. Okay, the bottom line here is 48. That's a special number because that's the median. So we don't need to have the list of numbers. If we know that, 48 was in the middle, right? The percentage that were younger than that, remember, it's half. Like if the median's in the middle, half the numbers are younger than 48. Now again, I don't want to muddy the water too much explaining this answer, but if we, like down here, we end up revealing that there was exactly 68, 68 people surveyed, and that there was no repeats, So all that really matters here with this question is we actually can kind of say that it's exactly 50% that ended up being younger than 48. We have like this even total number and no repeats. But in general, like let's say you didn't know this kind of information, all you had was this box and whisker plot, or all they were telling you was that 48 was the median. There's a reason why this question was kind of originally phrased as what is the best estimate, because whether it's exactly 50% or not, that's all you can really say, unless you know further details, details like this, I guess. But again, the median literally, oftentimes cuts the data exactly in 2 halves. And if it doesn't cut it in 2 exact halves, close enough to just say 50%, okay? And then to take that a little bit to the next level, what is the best estimate for the percentage of shoppers that were older than 32? Well, again, 32, they might as well be saying, older than the lower quartile or the first quartile. So older. So remember, like if we have 50% of the data here, that means like that's 25%, because the lower median cuts the 50% in half. So if this would have said younger than 32, then you would have said 25%. But older than 32, you just say 75%, okay? So that's how that kind of works, The middle number cuts the data in like this is 50%, this is 50%, even though they don't look the same, like width, it doesn't matter. The fact that this whisker looks shorter and is shorter than that whisker it doesn't matter as far as like that this is 25% of the people represented here, and then this is also 25% of the people represented. This last question, once again, has to tell you that there's 68 total shoppers, because this one's saying how many of them were older than 55. 55 is the upper median, so I mean, if it would have asked for a percentage, you would have said 25%. But they literally want to know how many is that? Like what is 25% of this grand total? Well, all you really got to do is figure out what 25% of 68 is, or like what's 1/4 of it, and it's 17. So that is how you should have answered those questions, and I believe that pretty much does it for part 3, and I think this entire video.